We're going to look at building a block diagram of an entire system from a bond graph model. So on the screen you see one that has a transformer element, and it has um, an I and R on the right hand side, a C and an R on the left hand side, and it has been numbered, and the causal marks and power flows are all indicated. So how do we build this block diagram from here? What we're going to do first is we're going to write some steps in here. Everything we do is systematically here. So this we're going to say, I would say number the bond, the number the bonds, um, you were saying in the entire system. So that's the first step. We have done that. Causal marks are in there. And then I would say the second thing you have to do in here is to do number 2, let's say. We're going to say, I would say lay out a structure with the efforts and flows. I would do something like this. Efforts on top, flows on the bottom. If it is a vertical one, I would say efforts right, and flows left. Very good. Let's try that. So what we're going to do is we're going to come in here and see if we get my drawing tools here. I am going to use this and say, okay, this is going to be effort number 6 for corresponding to this. This is going to be flow number 6 corresponding to this. And now on the vertical one. This is going to be E sub 5, following what I'm saying, vertical on the left, the efforts, and the flow A sub 6 on the right hand side. That's over here. See efforts on top, this one, flows on the bottom, efforts left, flows right. And then I am going to lay out the other two that I see here. This is an E sub 3 and an F sub 3 in here. And then you have, this is obviously there is a TF element, but in here on the other side, you have E sub 4 and you have F sub 4. And then you have in here this connection in here. This on the left, this on the right. This is an E2 and an F sub 2. And this one on the right hand side like that. This is going to be an E sub 1 and an F sub 1. So we have done step number 2. We just laid out the structure with the efforts and the flows. Now, what we need to do is go here and do a step number, what I would call it step number 3, which would be, I would say draw the individual constitutive relations, of each element. Obviously, that's why I say individual. So let's just do that. On this one here, why don't we have to say here, you could say consider the you know, the causal marks, um, you know, determining which is the output, which is the input of each element. You know, I'm just going to put a little note here, output and input of each element. So in this case, you see, let's just go to the left. Doesn't matter where we start. So here on this, the input to the R element obviously is f sub 6. So that sign has to be like this. I'm just going to maybe change colors just to put the signs in here. You know, this is f sub 6, and of course e sub 6 comes in here. So this is the output. Now in this particular case, take a look here. What's the flow to the C? The input is the flow, see? And the output is the F or D sub 6. We're going to do it on all of them. Here is your TF element. The E sub 3 is the input, and E sub 4 is the output on this case, while F sub 4 comes in this way, and then goes like that. See, so we are putting the directions of the signals in here. The effort is the input, obviously, and the flow is the output because of this form. See, flow down, effort in. Here, flow is in and effort is out. So this has to be like this. And then this is going to be like that, yeah? Very good. We put all the signs. So build the constitutive relationships right now. So let's just do this. In this case, what you have is this comes in into a gain like this R. Another here, you produce E. See, so this is the constitutive relationship of this one. In this particular case, is integral forms, you see. So in here, F goes in, and then of course gets integrated like that with 1 over S, and then gets multiplied by 1 over C, and that is this element. This one, E sub 3, gets multiplied by a factor or a gain in this case of M of the transformer element, and the same thing is true on this side. And then there we have like this. This would be M like that. This one on this side over here, the effort is the input and the flow is the output on the I. So this is also integral form. So what happens here? In this case, you could say that here you have integration as 1 over S, and then obviously we have a this blocking here, like the Similic notation, 1 over I in here, I2 in this case. If you want to put it over here also, C sub 5, that's fine, so you don't confuse. So we are done with all these individual constitutive relationships so far. We only have left the R. So in this case, it is the same causality between this and that. Are the same ones, where actually the effort is the output. So this gets multiplied by, if the effort is the output, is F times R that we do, right? So in here, this would be like this. Now we have gotten to the point where our bone block diagram is taking structure, is taking a bit of a shape in there, but now we need to go to the next step, which is draw the connections. In this case, the 0 and 1, 0 and 1 connections. Okay, so in doing this, we need to keep in mind 0, all efforts are the same. Flows sum. On the one junction, all flows are the same. Efforts sum. Yeah. Yes.
On the transformer.
Okay, so now we have the individual constitutive laws written. Just one clarification in here, which might be helpful. You see here on the TF, the input of this times these modules produce this output. So that means E sub 3 times in number produce this output. You know, whether the notation you use M or 1 over M, all we're doing is just a number, you know. On these ones, you see the flow is the input to the TF, and this is the output, and that's what you're seeing. Flow F sub 4 times the same number equals flow 3. Okay, having said this, now we need to go to step number 4 to draw the connections for the zeros and ones. And how are you going to do this? How are we going to do this? First, we're going to do this one on the left-hand side in here. Because it is a 1, all flows are the same. So I'm going to change colors just to illustrate how we do this connection. So in here you see, for all flows be the same, I would connect it like this, see? See? Like that. Yeah. And then over here, you have to add the efforts, see? Excuse me, yeah, this is not a 0.
It should be
Junction.
0. That one should be a 0.
Which one is a 0? This one?
That one. Yeah, that should be a 0.
You told me was a 1?
I told you a 0 and it went up, you put a 1 in there.
Okay, just a small correction. I think we are having it already like this one in here. So, and this is correct. So let's keep it like this. I would have preferred it with a 0, but in here the flows are the same. So so all flows are the same, but the efforts are going to add. Now in here you see these are the connections in here like this, and then you have this in here. Now keep take a look at here the way the signals are drawn here. It's like the effort here comes in, the effort comes here, and then the effort goes out of here. But the summation of this, in this particular case, is controlled by these half arrows. And in this particular case, all the half arrows are out. So you can say, if you make a convention that whatever comes in is positive and whatever goes out is negative, then you could write, you could draw it like this. Or you could say simply that f sub 6 plus f sub 5 plus f sub 3 is equal to 0. Now, this equation is, the one over here is not written in this form. It's not written in the form equal to 0. You see, you have this 2 coming, E3 out. You see, I need to correct something. I did something terribly wrong here. It's not F's, the E's is what I'm talking about. So let's just do it again. Let's try again. This is E sub 6 plus E sub 5 plus E sub 3 is equal to 0. But the way it is in here, it's not like that. E sub 3 is going out of this summation. So the equation, this same equation should be written as E sub 3 is equal to minus E sub 6 I minus E sub 5, right? Same equation. But now I have written it this, but it's controlled by the arrows. So this one in here, E sub 6 and E sub 5, should have a negative sign like that. And then we're fine. This one over here, you have another one in here. This is going here. This should be like this. Yeah. And then this one in here would be for the summation of the efforts. So let's make the connection here to this, like that, and this one like this. Here it's very clear that f sub 4 is equal to f sub 2 plus f sub 1. What comes in here equals to what goes out. Or again, the summation of all three equal to 0. Same thing. But the way it is written in here, it is as if it's in terms of, yeah, same error again. Yes, it's the e's. So let's just do, this is like E sub 4 is equal to E sub 2 plus E sub 1. That's the summation of the efforts. And the way it is in here is as if E2 is the output. The same equation could be written E sub 2 is E sub 4 minus E1. And that fits with this. So E2, if you write it in this form, despite the fact that this is controlled by the arrows, because that's what controls the sum, the form of the equation has to be the way the graph wants it. So in this case, this would be a plus, and then this E sub 1 would be a minus, and then this would complete the entire block diagram for the entire system.